In 2017, Grenfell Tower was engulfed in fire with the fire spreading along its facade. The incident claimed 72 lives, and it is one of the most severe fires post-World War in the British Isles. This, however, is not the first incident where fire spread quickly along the facade. More than 40 years ago, the Summerland fire in the Isle of Man claimed 52 lives, and it shares many similarities with Grenfell Tower. One of these similarities is the presence of facade cavity. While there are many different designs for building facade cavity, the basic build-up consists of a wall, insulation, cladding, and a cavity. The purpose of this cavity is often to allow ventilation to remove moisture in the system. This will prolong the lifespan of the facade. However, the introduction of cavity has also allowed fire to spread rapidly via the cavity. This is due to chimney effect that can elongate the fire by up to 5 to 10 times its original size in open air, depending on the facade cavity width. When the facade system does not have combustible insulation, flame height tends to increase with decreasing cavity width until the widths are small enough to suffocate the fire of oxygen. This decreasing cavity width and increased flame height results in an increase in heat flux on the cavity wall due to irradiation, making the system more vulnerable to fire spread. However, when combustible insulation is used, facade system flammability becomes more complicated. This is due to larger cavity width also increases air entrainment, and this air entrainment increases heat release rate due to the burning of insulation. These two conflicting effects by cavity width meant that the most severe fire is not necessarily the system with the smallest or largest cavity width, but somewhere between, which we are still not able to pinpoint. The objective of my project is to understand how facade system flammability is affected by cavity width. To achieve this, we have performed experiment to validate numerical model. This numerical model will then be used to study various facade configurations to understand how facade cavity width affects its flammability. With this new knowledge, we hope to provide engineers the tools to design a fire-safe facade system. Thank you.